Hello everyone. Hello guys. Welcome to Pantech Solutions and welcome to this session for development of deep learning architecture, which was organized by Pantech Solutions and the Institution of Electronics and Telecommunication. I warmly welcome you for this session, guys. And there is little bit instruction for attendees. The link will be given in the description. You just please fill up the attendance form, which will be given in the description. And if you are facing any audio issues, you can ping it in the live chat. Good morning everyone. So I just need to know the audio, whether is it good. Thank you, Karthik, Ashok Kumar. Good morning everyone. Good morning. I need to know the audio quality, whether is it good. Okay, thank you QU Education. It's clear. Thank you so much. So before continuing into the session, hope you are all in safe. This quarantine is for us and not for learning, right? So stay learning. So this session will teach you about deep learning and designing those architecture. So we'll start the session now. So we'll move on. So initially this was organized by IETE and Pantech. So about IETE, it was founded in 1953 and it has up to 1.25 K members and 64 centers. And then IETE focus on technical meetings, conferences, symposia, exhibition, and they are also publishing some of the technical journals. And they are also conducting some of the IETE based examination based on engineering, which is known as DIPATE and ALCCS. So those kind of examination also conducted by IETE. And then about Pantech, it was established on 2004 and it has up to 7 branches and 100 plus teams. And we are having R&D, that is Research and Development Center in Chennai. We are the manufacturer of lab equipments and funded projects and retail store for industrial and engineering products and projects. And we are almost conducted 1500 plus workshops and 250 plus FDP programs and 100 plus seminars and hands-on trainings. So for engineering and diploma students and Pantech technology. So this is our goal, to gain global leadership in providing technological solution through sustained innovation. So here we are having wide variety of technologies based on engineering. So first, initially, if we take electronics, we are the manufacturer of microcontroller boards like 8051 and microprocessor boards like 8086. And we are also manufacturing of FPGA boards and interface modules, sensors and lot thing. And if we go for electrical, we are providing industry-based solution for renewable energy systems and e-vehicle. And we are also selling motors and drivers and electronic equipments and electrical equipments. For if in going for mechanical, we are designing 3D printing and we are providing industry-based solution for robotics as well as other mechanical products. And the main thing, brain computer interface, we are having our own product which is BrainSense. It is for brain and computer interface like EEG headband, which is known as a BrainSense. And if we're going for software, we are having industry based solutions for augmented reality and virtual reality, and we are providing Android and iOS development, cybersecurity, cloud and mobile computing with IoT. And about AI, so we are providing industry based solutions for machine learning and deep learning, NLP, which is natural language processing, chatbot, blockchain, data science, and AI board, which is needed for who is starting up with artificial intelligence, who should have a hands-on training. They can get artificial intelligence training development boards. So before going on to this agenda, so I'll introduce myself. This is Sanjay from Pantech. I have been working in artificial intelligence for past 3 years. So this is up to me. And if you have any doubts, you can ping in a live chat. Good morning again. So we'll go into the session. So in the agenda, so before going into the deep learning, we should know why is deep learning. So general agenda is general talk on artificial intelligence, and then about deep learning and its libraries. Why? Because deep learning work on based on libraries. Lot of libraries are there about the libraries, and deep learning algorithms such as artificial neural network, recurrent neural network, and convolutional neural network, and we will design some basic architecture by using deep learning, and then application of deep learning, and then demo on character recognition and emotion recognition. Character recognition is based on image, and for emotion recognition we are going to deploy deep learning for real-time emotion recognition using deep learning. Okay, so before moving on, so what is artificial intelligence? So artificial intelligence is nothing but a kind of machine which needs some of the knowledge to perform some application. For example, if I take, I'm going to assume on a baby. So for that baby, it doesn't know about anything. It doesn't know about any books or pen or anything. Doesn't know about anything. So from its childhood itself, we will start or we will teach something. So teaching in the sense based on image, based on the voice or something. For example, if we take kind of one book. So this is kind of a book. So this book has some pages. So we will start reading, or we'll start seeing this book. Child will visualize it. So this is kind of a book. Okay, and then if you take some kind of pen, so this is kind of a pen. So pen will be look like this. So the baby will start learning itself to gain the knowledge about pen. So after some years gone, if I show this to the baby, it will say this is the book and this will be the pen. So likewise, we are going to give the some intelligence to a machine to do some applications. It may be vision based application, or it may be voice based application, or it may be any application. Okay, so this is the thing, and then we'll move on. So this is the artificial intelligence. But in the artificial intelligence, even though there is some lot of positive thing, there is also a negative thing also. There like security and lot of thing is there. So that's why Elon Musk has also told AI will be the best or worst thing ever for humanity. So same as like Stephen Hawking is also told, like success in creating AI would be the biggest even in human history. Unfortunately, it may be, it might also be the last unless we learn how to avoid the risk. So that's right. Even there is a lot of negativities or lot of problems and risk in there. We should learn how to use artificial intelligence in the right manner. Okay, so this is the artificial intelligence. So this is the circles of artificial intelligence. So in the artificial intelligence, the coverage area is artificial intelligence, and then second is machine learning, and inside the machine learning there is a deep learning. So in depth of machine learning, which is deep learning. Okay, so and then if we go for deep learning, okay, in the deep learning, what is the difference between machine learning and deep learning? So if you take, but deep learning is a subset of machine learning, but it is inspired from the structure of the human brain. Okay, so this is inspired from the structure of the human brain. So let us take this area. So here there is a brain, right? So here there is a vision or hearing aid, anything. Okay, so we will hear or we will see something, and it will be processed in the brain to make a decision like this is the apple, or this is a tree, this is a leaf. So kind of recognition. Oh, this is the process. Okay, so in that process, so this is the vision, brain, and then recognition for our human being. For that machine, so it will be completely same like structure of for a brain. For instead of vision, we'll put up a data set for training the brain. Okay, so the neural network will train itself to give you the model for trained data set. The data set, it may be anything. It may be vision based. If it is a mission based training, for example, if the machine want to classify this book and that pen, what we can do is we can provide 1,000 images of book and 1,000 images of pen, and we will do the training. Resulting model will give you the accuracy and the loss to recognize the book and then pen. So if it got a very good accuracy with 99%, it will classify the book as a book properly and pen as a pen properly. If the accuracy is very lesser, like for example, if it is 40% of accuracy, it may classify pen as a book for a poor classification with a poor accuracy. So that's why main motive was to have a better accuracy and with very less loss. Okay, for that the main requirement for the deep learning is to provide tons and tons of data. Okay, so we need to provide lots of data, so that kind of data gonna be fed to a training model. So on the training we will process each data, and we will to generate the accuracy with the loss and then with the model to recognize that object. Okay, so we need a data. Okay, and then we need some computational power to train it, and it need to be recognized. Okay, so why is deep learning? So we'll see the difference between the machine learning and the deep learning. Okay, so in the machine learning, if we take machine learning, we want to classify the futures. What future is? For example, if I want to detect a person, okay, if I want to detect mean person or face means, so in the face we are having that face future, right? Face future in the sense that we are having eyes, nose, ears, mouths. So these are some parts in the face. Okay, we want to identify the future of the face, and we have to specify the future in the machine learning or any other image processing application. Okay, so if you want to going with the deep learning, the main thing is to do the automatic feature extraction. Automatic feature extraction is nothing but it will automatically identify the future of any image or something. For example, if I take apples and bananas, what are all the futures? Can you tell me? So in here, these two fruits have some of the features like color, right? So apple is in red color, banana is yellow color, and then second feature is shape. Okay, so that is like spherical like structure. This shape is different, right? So color and then shape is the two features are there. So okay, if you want to deploy it in machine learning or some kind of any other image processing algorithm, we need to specify, or we need to design a future extraction thing separately. Okay, the main advantage of deep learning, it will automatically extract the future from the given data. Okay, I'll give a bunch of data or tons of data, for example 3 apples and 3 bananas. So it will automatically study the pattern in the given data set to identify the features, and it will give you the model with a high accuracy or training data. So after we got the model, we will load the model to load each and every images to have a predictions. So whether if I give the apple image, it should recognize the apple. So this is the deep learning which is used for. So let us assume for if it's a baby, so baby will identify those kind of data from the vision based. For if your age is 25, for 25 years you have been seen lot and different type of apples like green or red, or if I cut the apple into 2 pieces, if I show without color of red, you can able to recognize that is the apple, because you have already cutted the apple and you have seen that cutted part of the apple. So you can able to identify that is apple, even you have cutted or even you are squeezed every skins of the apple, but you can able to identify. Okay, that is kind of thing which is the knowledge you have for 25 years. So within this short span of time, we can't make camera to move on to see and vision. It will take more time. So instead of that, we will provide tons of images in the form of data. Okay, so on the form of data, here there is a challenge, right? For example, if we take 25 years, okay, if I take 25 years, for 25 years you have been spent 25 years for learning to recognize every object, or even though for 10 years is enough, for 10 or 5 years is more than enough for recognizing every object, if you have seen every object. Okay, so now we are having tens of images. For example, 10 lakh images of apple and 10 lakh images of banana. So now we have to feed those knowledges to the machine, for example, to train it, to train the image. Okay, to train the image. To training the image, we need lot of computational power which can be given by the system or machine. Okay, so for giving the computational power, so first thing we already have is a CPU, which is central processing unit, which is focused on latency, which is focused on latency, and then it will have less bandwidth and not suitable for real-time application while it go for artificial intelligence. Okay, so if for example, so this is the CPU. Okay, and then we'll move on to the GPU, that is graphical processing unit. Okay, if we're going for graphical processing unit, it is focused on thread with the parallelism, and it will have a very high bandwidth and easily programmable register. It makes this a bandwidth optimized. So due to that, so graphical processing unit can do more heavy application than a central processing unit. For example, if I take a normal deep learning application to classify the apple and the banana. Okay, now I am going to have 10,000 or 10,000 images of apple and 10,000 images of banana. Okay, so if you take 10,000 images of apple and 10,000 images of banana, I am going to do the training in the normal machine. Okay, if you take normal CPU will take up to 2 or 3 days or even 1 week based on the data set. It will take more days even. For example, if I take 10 lakh images, it may take 2 months or 3 months to train by using a central processing unit, and it may get a lot heater, lot heat, it may get fault, so lot of issues while using a central processing unit. That's why we are moving on to the graphical processing unit, which can train more number of data in the short period of time. For example, if I take same quantity of images like 10,000 images of apple and 10,000 images of banana. So if I am going to do the training in central processing unit, it will train up to, it may take 5 days. For example, if you take 5 days, if I am going to do the same data set of 10,000 images of apple, banana, I am going to do the training in now GPU. So GPU may train within 20 seconds. Okay, sorry, within 20 minutes or 15 minutes based on the data. Within 5 minutes even it can able to train it. Okay, so that's why we are moving on to the graphical processing unit. Okay, for example, if you take normal, if you need some kind of example or suggestion for central processing unit, normal CPU, we are having our PC, right? This is central processing unit. So okay, if you are having graphical processing, if you need graphical processing unit, you know about NVIDIA and AMD, everyone is using. So those who are gamers, nowadays every laptop is having inbuilt graphics card, so which was provided by a lot of industries like AMD or NVIDIA, right? So they are also providing industry-based solution or industry-based boards for development for artificial intelligence. Let me take NVIDIA's boards such as NVIDIA Jetson or NVIDIA Jetson Nano or NVIDIA Tegra. Lot of industries are trying to provide hardware for artificial intelligence for training aspects and as well as real-time application aspects. For example, if you need it low cost, you can purchase a Raspberry Pi. It may cost only 4,000. If you want to have a NVIDIA kind of graphics card, you can buy a Jetson Nano, which will cost you around 10,000. So these are all like suggestion graphical processing unit for hands-on practice for artificial intelligence. Okay, if you have, you can have your laptop with the graphics cards also. Okay, so we'll move on to the deep learning libraries. So in the deep learning in the Python, it is completely based on libraries, right? So it kind of lot of libraries in there for real-time deep learning applications. Okay, on that first TensorFlow was developed by Google. So it has completely a numerical computation using data flow graphs. Okay, it can also run as a backend for the Keras. And main advantages of Keras is it has distributed computing on multiple GPU. For example, if you take a single GPU, okay, I'm going to process 10 lakh images of apple, 10 lakh images of banana. Okay, I'm need to train it. So if I'm going to process in single GPU, it may take 20 minutes. For let us take, if I take it may take 1 hour. Okay, let us take it may take 1 hour for in a single GPU. But I can have a multiple GPU have distributed training over every deep learning, every GPU. So the training may occur very fast. Instead of 1 hour, it may get trained within 30 minutes. Okay, so that's why that is the distributed computing on multiple GPUs. And then Keras. So Keras is very easy to use framework of deep learning, since it has a lot of trained model or lot of models in Keras. For example, it can also run it both CPU and GPU. But it won't support multiple GPU. But the same code can be run on CPU as well as GPU, but it won't support for multiple GPU. And it will use Piano or TensorFlow as backend. Okay, so this is majorly used for deep learning application. Keras, it is source and everything is available very easily, very easy to use this one. And then MXNet is also more popular because it can be it have multiple language bindings. For example, it has Python as well as C++ and other C++ and other programming language also can be done using MXNet for deep learning algorithm. And Caffe is also the lot of used model which is has very high performance, like processing speed and everything. It is very high performance, and tuning is very easy in the Caffe model to tune the parameters of neural networks. And convolutional neural network and recurrent neural network was extended by the Facebook company, and then CPU and GPU. So it will run at both CPU and GPU. Okay, and then SciPy and NumPy is kind of basic libraries which is required for array kind of applications. Or why? Because if you take any image processing application like deep learning, if you want to recognize some of the application or some of the thing, so there which requires some image, right? So in the image is nothing but a matrix of pixels, right? It is a kind of matrix, like it will have both rows and columns which have one bunch of pixels. So that is kind of a matrix array kind of thing. So to process those things we require SciPy or NumPy. Okay, so most of the new features is belong in SciPy rather than NumPy. Okay, this is just a suggestion. And now if we going for PyTorch, so torch with a Python which is known as a PyTorch. So this is kind of old machine learning and deep learning library. It also supports CUDA for parallel computation, like paralleling, parallel processing, so that performance and stability will be increased. So it also worked in supervised image problem with convolutional neural network. And I wish to say that is, so we already seen the GPU, right? So in the GPU, so now if you assume that if you have only CPU, okay, central processing unit, your laptop, okay, that can also be accelerated by some of the GPU cards. So the one thing is, first you can have a graphics card in your PC. So if it is not possible, you can buy lot of compute stick is available. That is Intel's neural compute stick, which is model Intel Mobidays, and neural compute stick model 2. There is two GPU like hardware acceleration USB stick, that is kind of like pen drive. You can plug it in your CPU to have acceleration on hardware based on the application, like real-time application for artificial intelligence. Okay, this is just a suggestion. So okay, so if you have any doubts, you just start pinging in the live chat, and after finishing the session we'll have a question and answer session, so that we will give you the answer for every questions. Already some of the people are questioning. Okay, so I'll reply at last. So before going on to the deep learning, so I already told you deep learning is for is inspired from the neurons of the human brain. Okay, so in the human brain there are billions and trillions of neurons, right? So on the neurons, so it has separate parts, right? So for example, if you take dendrites, so this is the cell body, and then axon, and then synapse. Okay, so these are the parts of the neuron. Okay, so neuron is responsible for every action which you do. For example, there is some fire, lighter, some fire is there. Okay, some fire is there. So now I'm going to touch the fire. Okay, now I'm going to touch the fire. I'll feel the heat. Okay, I'll feel the heat, so that I'll suddenly take my hand up, right? So this is based on the sensory. Okay, so whenever you are feeling that heat, there will be a sudden trip in your neuron, the certain neuron which is responsible to have a physical movement. So at the time of you felt the heat, you suddenly take off the hand, right? So these kind of neuron will be activated based on the sensors, or based on the sudden action or anything. Okay, so this is the neuron. Okay, right? So on the neuron, so what we are going to do is, so we are going to design kind of application which will gonna be the same as like our human brain's neuron. Okay, so here function gonna be the mathematical or any activation functions. Okay, so for example, so when our human being going to touch the fire, so it good sense. So some of the functions should activate the neurons which is responsible for the physical activity, so we will suddenly move the hand, right? So these are the basic physical activity which is activated by the some of kind of neurons, right? So what is mean by activation function? So before going on to the activation functions, there are several kind of activation functions out there. which is step function, sigmoid function, tanh function, and ReLU functions. So a lot of activation functions also there. Okay, so this is activation function to activate the certain neurons to give you the output or to make a decision. So if it is in a classified state, if I am going to classify same apple versus banana, so it should classify either it is apple or banana. It should take a decision either one, like apple or banana. So that kind of activation function which is required to activate a certain neuron to make a decision or to pass into the neuron. Okay, so if you see, this is the neuron. So it has dendrites and cell bodies. So same as like structure, we are going to have a deep learning model. So this is the deep learning model. So this is the deep learning structure which has inputs. So input, you can take a kind of image. Okay, that is a image, that is a input, and then we are going to take a neuron. Okay, which gonna activate the activate the certain function based on the data set or based on the image. Okay, based on the function or okay, kind of thing. And then activation function. So neurons, from the neurons it will give you the weights and everything. So activation function will predict or will make a decision based on the data set which is have already, and it will give you the output. So output will nothing but a decision. Okay, and then activation function. So first we are going to see a step function. So in the step function, so we already told you that activation function will activate some kind of functions. Okay, so if you take a kind of activation function, so activation function, there is a step function. In the step, from the diagram itself you can able to understand like zeros or ones. So if the value which is obtained as less than 0 or less than 0, it will be 1. Sorry, it will be 0. Okay, if the value of x is greater than or equal to 0, then output will be 1. The value of x is less than 0, then output will be the 0. Okay, so normally neural network uses back propagation and the gradient descent method to calculate weight of the different layers. Okay, I'll tell you the later on about the back propagation and gradient descent method. So you just remember calculating weights in different layers. Actually, for every layers we need to classify weights. Okay, so that is the purpose of back propagation and gradient descent method. But in the step function, it is not differentiable to 0. It can't do the gradient descent method, so it can't update the weights. Okay, this is the disadvantage in the step function. Then why we are moving on to the sigmoid function. So in the sigmoid function, this is the formula for sigmoid function, that is 1 divided by 1 plus e power minus z. Okay, so that is nothing but exponential. So if the value of x is infinity, if the value of given value is x is infinity, then the output will be 1, and if the value of x is negative infinity, then output is 0. Okay, and it also captures a non-linearity in the data, so that it can able to identify or it can able to do the non-linearity application on artificial intelligence. Okay, it can also use gradient descent and back propagation method to calculate the weights. So whereas step function can't able to do that, since it is non-differentiable to 0. Okay, so this can be do that gradient descent and back propagation method, and this output is ranges from 0 to 1. So for example, if you say this axis, so it will start from 0 and it will ends at 1. Okay, after the straight slope increase, and then it will get saturated. Okay, but it will start from a 0 and it will end at the 1. Okay, so you know the difference between step and sigmoid, right? So step can't do back propagation and gradient descent method, but sigmoid can do. And sigmoid also captures the non-linearity data to identify or to do artificial intelligence application for non-linearity data. Okay, and then we'll go on to the tanh functions. So tanh function is nothing but a rescaled version of sigmoid function. Why we are going like this rescaled is, so that sigmoid function will start from the 0 to and it will end at a 1, right? But it will start from -1 to 1. Okay, so that's why it's called as a rescaled version of sigmoid function. And better learning rate, which is nothing but kind of has good accuracy. So good accuracy on learning, so it needs higher gradient. So in sometimes for the data is centered around 0, derivatives are higher, so when compared to the step functions and everything. Okay, if you're going for ReLU function, it is known as a rectified linear unit. Okay, if any negative input is detected, it will return 0. Okay, otherwise it will return the same value which is written back. Okay, for example, if it's a ReLU, so if the sum of the input is coming in, Okay, if the input is gonna be, if the output, if the input is gonna be the negative, it will return a 0, otherwise it will return the same values. Okay, so there is other subcategory is also there, leaky ReLU function. So that is also same kind of ReLU, but like returning the same for positive. So for example, if the input value is same positive, it will return the same number as like a ReLU function. But for negative value, it instead of returning 0, it has have a constant slope of increasing the values. So like it will start increasing like a signal which is given in the graph. So okay, so this is kind of a ReLU. And then softmax function, you just want to understand this softmax function because I'll show you this softmax function, how to design it for deep neural network. Okay, so if you take a softmax function, so this is also have some kind of graph, but here softmax function is used in the last layers of the neural network instead of ReLU, tan, or sigmoid. Okay, that is based on the requirement. And then it is used to map the non-normalized output of a network to a probability distribution over predicted output class. For example, this will be this softmax function will be the last layer or last layer of the convolutional neural network, any neural network, to do a prediction, to prediction class, to do a prediction class, which is nothing but, for example, if you take some same bananas and apple classification, at the final stage it should make the decision whether class is 0 or either class is 1. For example, if the class is 0 means will take as an apple, and class 1 means will take as a banana. Okay, so at the last stage, at the final stage, based on the neurons activated, it should make a decision whether the result or prediction which is apple or banana, so either class 1 or 0. Okay, this is made on softmax function. So this is the softmax function kind of equation we'll discuss with later. Okay, so if you take deep learning algorithm, there are 3 types on deep learning algorithm. So first one is artificial neural network, and then second one is recurrent neural network, and third convolutional neural network. So on the convolutional neural network are more used for image processing kind of application. Recurrent neural network is used for natural language processing application. Okay, so I already told you that vanishing and exploding gradient, so that kind of issues. Okay, it is a very common problem in every neural network. Okay, which is associated with the back propagation. So back propagation is nothing but like so from certain layer to another layer, so it should follow the weights. Okay, so for example, here I will say, so weight of the network are updated through back propagation by finding the gradients. For example, there are 2 layers. Okay, so first layer and then second layer. Okay, so from the first layer and the second layer, weights and everything will be passed over from the first layer and the second layer. So there we'll need to do a back propagation like feedback or something to identify the previous input to find by finding the gradients. Okay, so those kind of thing which is known as a back propagation. Okay, so and then when the number of hidden layer is high, then the gradient vanishes or explodes. For example, if you take some convolutional neural network, it has intermediate lot of layers. Okay, so even though everything it should pass over through the each and every layers. So in the each layer, now hidden layer is high. If the number of hidden layers are very high, while passing from single layer to another layer, for example, here we are having up to 6 hidden layer in the intermediate. Here there is a input, here there is output, and intermediate there is a hidden layer. So if the weights or something, it will be passed over from each and every layer. There may be a possibility of some of the gradient values, it may get very smaller, which is known as a vanishes. So while passing through every layer, when the number of hidden layer is high, it will get vanished or it will get exploded. So it leads to instability in network, so that unable to learn, it can't able to do the learn properly, the accuracy will be very less. Okay, so the explosion is occurs through exponential growth by repeatedly multiplying the gradients. Why? Because so here we know that, so while passing large number of layers, it is causing that gradient or that vanishing and exploding gradients is occurring, right? So by multiplying those gradients through the network when the value is larger than 1.0. Okay, so why? Because like for example, if you take value is like explosion is occur through exponential growth by repeatedly multiplying gradients. So gradient will be multiplied throughout the network layers that have values larger than 1.0. So those values I will discuss with later. Okay, and this can be fixed by redesigning the network. Why? Because so we are having multiple or huge number of hidden layers. Okay, by redesigning the network. So this is the first possibility to reduce the vanishing and exploding gradient. And second, long short term memory networks. So this is kind of thing which will remember the previous weights. So for example, so if you take a start input and then output, okay. So now in intermediate there is a kind of 10 to 6 hidden layers. So weights or gradients will be passed over from each layer. So there, if it goes very smaller, so it will get vanished. So to prevent that, we will have a short or long term memory to remember the previous layers gradient, so that it can't miss that gradient, so that it can't vanish. So by using that, we can do that. And also there is gradient clipping methods to avoid the vanishing and exploding the gradient. Okay, so if we first take artificial neural network. So first, what is you mean by artificial neural network? We already tell about the neurons, right? So first it will take the input and it will process it, and it will give you the output. Okay, so there is a input. So here this is the input layer, and this is the hidden layer, and this is the output layer. Okay, so here there is a 3 layers. Okay, so input and then hidden and then output. So this white color circles are known as neurons. Okay, every neurons are connected mutually, right? So and then artificial neural network. So in the artificial neural network, it will learn any non-linear function. So non-linear function, so it is also known as a universal function approximator. So you know, an artificial neural network, it is also known as a universal function approximator. So it is nothing but activation function introduce non-linearity property to the network. So it will identify the complex relation between the input and the output. So if we take a complex kind of data, complex means for example, if we take apple and then banana, but it is not a complex, right? It is not a complex. It is easy to understand. Why? Because there are two features common. There is no feature in common. Only thing, to color and then shape also completely different. If you take complex kind of suggestion, if we take bears, let us take a bear. Okay, there are polar bear and then normal forest bears are there, right? Polar bear and normal bear is also while based on the structure or based on its structure, it will be the same. Okay, but only the colors will be different, right? Why? Because both are same in the structure. It will be very huge and have nails and everything, but it is different. Polar bears is going to be the completely pure white. Okay, so only the color will be different, but there is some common feature also there. Those kind of thing is complex relationship, some kind of complex kind of classification based on that. Okay, so for example, so output of the each neuron. So here if you take, this is the neuron, this white circles are the neuron. Okay, so output of the each neuron is activated of weighted sum of the input. Okay, so for example, this is the neuron. So from the neuron, it will give you the weighted. Okay, so output of the each neuron will be activated is the activation of weighted sum of the input. So if you take, this is the input. Okay, so this is the hidden layer. In the hidden layer, there is a neuron. Okay, so this output of the each neuron. Okay, this will be activated with the weighted sum of the input. So here there is a input. So weighted sum. So it has some weight. So weight with the sum is the product of the neurons. Output of the neurons. So if there is no activation function, network can't learn the non-linear functions. Okay, so it can't able to do the classification or thing properly. Okay, and then ANN is also known as a feed-forward neural network. For example, if you take this neural network, there is no any back propagation or back arrow in here, right? So this is input, and first it will be in the input, and then it will move on to the hidden, and then it will go into the output. There is no feedback or there is no like suggestion, or there is no kind of reference on the previous values in the output area or in the intermediate. So there is no feedback or back process. There is completely a forward process. So that is known as a feed-forward neural network. So that is artificial neural network is also known as feed-forward neural network. And main thing I want to say is, here if you take input and hidden layer and output. Okay, so if you take input and then hidden, in the hidden there is 4 neurons. Okay, So hidden layers, there is only one hidden layer, right? Except the input and output. Input is there and output is there. Only one hidden layer is there. If there is a more number of hidden layers, that is known as a deep neural network. Okay, here artificial neural network we are speaking about. But if you are having more number of layers, more number of hidden layers, which is known as a deep neural network, that is a DNN. Okay, so if you take RNN, so recurrent neural network. So if you take recurrent neural network, so there is, if you see the figure before when compared to the before thing and this one, so there is some back thing, like some feedback or something. Okay, so there is a looping system in the hidden layer of ANN is known as RNN. So on the ANN there is no any other looping, right? It is completely a forward projection, but here there is a looping structure. Okay, and main thing on RNN is recurrent neural network is it will capture the sequential information of the data. Okay, that is used to help to predict the words. For example, if I'm going to tell there is Alexa or Alexa in it, so okay, so the Alexa or Google Assistant or something in it. Okay, how are you? Okay, now I'm going to ask how are you. Okay, so first it already identified how are. Okay, how are, so two words. Okay, and then it should predict how are you or how are yourself, so it should predict the you. Okay, the third word which is based on the previous words. Okay, to predict or to identify those kind of words, so we need our help. We can be done with the help of recurrent neural network. Why? Because we are having a looping system in the hidden layers, so it will automatically identify the previous data, so that it can able to identify the dependency of the current word dependent based on the previous words to make a predictions. Okay, and then also it also shares parameter across different time steps. For example, so if you take a certain neuron, it will share those parameters at different areas, so like feedback or looping or anything. So it will share those parameters at every area, so that at the time of training there are only a few parameters. Why? Because it's completely shared throughout every neural network. Okay, and then it is also known as a time series version of ANN. Common recurrent layers are LSTM, that is long short term memory, and GRU, greater recurrent neurons. So we already discussed about long short term memory. Why? Because to avoid the vanishing gradient problem, we need to have a memory on the previous weights which we obtained from the input layer from the previous layer. Okay, so here there is a hidden layer. So if you are having multiple number of hidden layers, so we are going to obtain lot of weights data from the previous layers. Okay, at this instant it may, if it is more number of hidden layers, it may get vanished. To overcome that vanishes, here we are already seeing the previous data. Okay, in the RNN, so it will have a knowledge on like having a memory on the previous data, so it can't miss or it can't have a vanishing of a gradient. Okay, GRU is used to how much data need to flow through model. So for example, at the same time every data it can't be processed into the single area of the model, so the GRU, that is greater recurrent units, will help you to pass how much data need to be flow through the model at every time. So this kind of thing which is used for GRU. Okay, and then this application we already discussed, it is used mostly used in natural language processing. Okay, why it is for natural language processing? Because from the structure itself we identified this is used for it is based on the previous values also. So for example, for natural language processing is nothing but kind of chatbots or assistant based. So natural language processing is nothing but voice assistants like Google Assistant, Siri or Alexa. So this kind of Google Assistant, and chatbots like Hi Natasha. So it will based on the human requirement, it will reply back. So if I'm saying what is the weather now, okay, so it will automatically identify what is weather. At the last word it is dependent on the previous value. What is the weather? So there may be a now or tomorrow or yesterday. So there will be a possibility of word to predict the current word based on the previous values. The RNN is used. So that is recurrent neural network. Okay, since recurrent neural network has recurrent kind of connections, that is kind of feedback. Okay, and then convolutional neural network. So and then convolutional neural network, CNN learns the filter automatically to extract the right feature. We already seen this feature, okay, CNN. And then it also captures the spatial features, arrangement of the pixels, whereas ANN can't. Because if you take this is an image, let us assume this book is an image, okay, this book is an image. So this, in this image, it contains more like a matrix, like pixels with columns as well as rows, okay. In this pixels, it should identify the arrangements, either is it a row, either it is a column. So those kind of arrangements can be done by using the spatial features, okay. It can't be done in an artificial neural network, okay. And also it also follows parameter sharing like RNN. So like applying single filters in different part of the single image. So we already told about the parameter sharing, so that it can able to do it can able to do a very less number of input parameters. So parameter sharing. So here parameter sharing is ready to mention, like, so if there is a single image like this, okay, so I am going to apply the filter for complete image. Instead of applying the filter in complete image, I am going to apply a single filter in the different part of the single image. For example, if I take this book, okay, here first I will apply the filter in this part. So first I'll take this as a rectangle, and I'll apply the same filter in this part, and then I'll move the window to this part, and this part, like that. I'll move the same filter on the every part of a single image. So those kind of thing is a parameter sharing like RNN. And then I don't have recurrent connections like RNN. Instead, it have convolutional type of hidden layers. I'll show that structure of hidden layers. And then for convolutional neural network, convolutional and pooling functions are used as the activation function. We know the activation function is. Activation function is to make a decision, or to give the result or give the output from the neurons or from the weights, okay. If you take a first example, if you take a convolutional input image and the other filter, input image and other as filter on input image kernel produces output image. For example, I'll explain this convolutional layer clearly, just please be attentive. So for example, if I take a same image, okay, this is kind of a image. So in the image, I'll take the first part. This is the first rectangle. For example, this ATTI, okay, this is the first part which I'm gonna take, okay. Here this is the input image. So first thing is input image, okay. This input image is this part, and then I'm going to apply a filter of the same part of the image, that is a kernel. For example, this is the ATI. ATI is the first part which I'm going to take as a raw image. And then as a second thing, I am going to apply a filter for same part of the image, that is a kernel, which produces a output image which is known as a convolutional, okay. So and then what I am going to take is pooling. What is mean by pooling? Picking out the maximum value from the selected region is maximum pooling, and if you're taking a minimum value of a selected region, that is minimum pooling. So let us take a same image. So in the image there is a I'm going to take a first region, okay. In the first region, I will find out the maximum value of this complete pixel, or complete pixel of this region. So for example, this is a red, dark red, so this has the maximum values. So it will identify the maximum values from this data and will give you the output as that is the maximum value. So that is the output of this region. So if you find it's the maximum value, that is maximum pooling, and if it finds the minimum value, that is a minimum pooling, okay. And then we'll take a CNN architecture. So this is the convolutional neural network architecture, okay. So first here I'm going to do some kind of handwritten or character recognition using convolutional neural network, okay. For that, first what we are going to do is so I think some is hidden there, so I'll hidden up my camera now. Okay, so for example, if you take this convolutional neural network, so first we take image, okay, 28 cross 28, which is a binary image, okay, binary, or we can take as a grayscale also, okay. So we take some binary image of character number 2, okay. So this is the input image, which is 28 cross 28. So which is having a matrix, that is nothing but rows as well as column, that is 28 rows and then 28 columns. This is a square image, square kind of image. Inside that we are having character number 2. Okay, this is the first input layer. Okay, now can you tell me how much hidden layer is there? So here these and all like complete hidden layers, and except this one is a output layer. Okay, except these and all like complete hidden layers. Okay, this and also known as deep neural network. Okay, so we already told you convolutional neural network, which has kind of layers, which is what are the layers? We already said two things. One is convolutional layer and second one is pooling layer. Okay, here what we are going to take is first what the structure is mentioned is first we are to convolutional layer. Okay, and then we are going to take into the maximum pooling layer, and then again we are going to take second convolutional layer and second maximum pooling layer. So then since these are common thing which we can use. For example, if you need more kind of future extraction, for more kind of future extraction means we will use more number of layers to extract more number of feature. So layer is nothing but what is behind the layer, what the layer will do. So each layer will identify the sum of the future of the input image. So for example, if you take number 2, so it will identify the future. So for example, if you see this rectangle in here, so that is kind of C-like structure, reverse C. Okay, so it is kind of C-like structure, that certain square box. Okay, so that kind of part can be taken a certain future. So for example, if we take number 1, okay, we just compare that number 1 to 2. Okay, but number 1, it doesn't have this kind of future like C kind of curve, it won't be there. Okay, even it is a handwritten, one can't be written like curvy structures. Okay, so that is a kind of future. So every future will be extracted while passing through the each and every layers. Okay, so for example, up to here, up to this 3 layers, some of the images will be segregated, or some parts are segregated to do some kind of process or application. Okay, and then what you are going to do, apply is a flattening structure. So in the flattening structure, one minute I will do. So in the flattening structure, what I'm going to do is, so flattening is nothing but process. So for example, take this as a 2. This is a image. Okay, this is a number kind of 2, or this is kind of one image. Okay, it contains rows as well as columns. Okay, so let us assume this image contains 28 cross 28 rows and 28 columns. Okay, so now flattening process, for example, if you take this is the first row. Okay, first row, and then second, and then third, and then 4, and then 5. Okay, let us take 5 rows is there. Okay, and then first letter 1, and then 2, and then 3, and then 4, and then 5. So 5 rows and 5 columns. Let us take, this is the image which has a 5 cross 5 matrix, that is 5 rows and 5 columns. So on this is the image. Okay, so flattening process is nothing but first we will take this first 5 columns, or first single row. Okay, first we'll take the first row, and we will take the second row, and we will do the appendant here. Okay, so first we'll take the first row, and then we'll take the second row and we'll append it here. Okay, this is the second row, and we'll take the third row and we'll append it here. Okay, third row. So by taking a first row, and we will do the complete flattening process. So first we'll take the first row, and we'll take the second row and we'll append it here and here and here like that. So first single image will be flattened like a single row. Okay, so in the single row, 28 cross 28 multiple value will be there to have a flattening structure. So that is which is done in the flattening process, that is N2 channel. Okay, and then what we are going to do is, there are some kind of layers which is known as maximum pooling, and after that we are having a fully connected layers, that is the ReLU. So ReLU, there is activation functions. Okay, for example, so from here the data will be passed over through every layers, right, every neurons or every neuron. But at the, if you see the output layer, there are only 10 neurons. Okay, so only 10 neurons in the output layer, because here we are going to do is character recognition. So in the character, if we take only numbers, okay, in the numbers, numerical recognition, if we take numbers, so it only start from 0 to 9, right? If you take 0 to 9, so it will have only 10 characters, so only it will be the 10 neurons. Okay, so only it will be the 10 neurons. So in the 10 neurons, what we are going to do is we are going to take 10 neurons. So from by passing through the each layer, at the final stage, only one neuron gonna be activated. For example, if the character is number 2, while doing a deep learning algorithm or CNN architecture designing, at the final stage, if the accuracy and everything, every structure is right, then only one neuron get activated, gonna be activated, that is number 2. So if the neuron number 2 is that is third neuron is activated, the number which are given in the input is number 2, that is it is recognized successfully. Okay, to classify, this is the number 2. So recognize is done proper. So this is character 2. Likewise, so if I am going to give the character or input as number 3, okay, number 3 means, so fourth neuron will be activated to represent, that is number 3, which is shown in the image. Okay, this is the complete structure of convolutional neural network architecture. Here you can able to remove the hidden layers, and also you can do the training as well. You can check it out how it works without hidden layers. Why? Because without hidden layers there will be no lot of future extract can be extracted. So we need lot of layers to do a lot of extraction, like future extraction, or do the future extraction based on the inputs. Okay, so these and are like convolutional neural network. And then we are going to do a softmax classification. So softmax, we know that it is kind of one kind of activation functions. So that is a softmax classification. We are going to do a simple application. Okay, so how to design and everything. Okay, so and then what we are going to take is first thing we are going to take a image. Okay, same image, it has 28 cross 28. Okay, so don't bother about the grid lines, I just shown it for reference, but that matrix is represented as 28 cross 28. Okay, so first thing I'm going to take image 28 cross 28, and second thing what I'm going to do is I'm going to flattening that image. So for example, if this is the first row and this is the second row, likewise it will go up to etc about 28. Okay, on the columns itself it is also has 28 columns and 28 rows. Okay, this is the flattening process. What I'm going to do is I'm going to do the flattening. So flattening is nothing but, first I'm going to take this grid line, this rows, so I'll put it up here. Okay, so 1 2 3 4 5, so I'll put up 5 rows, 1 2 3 4 and then 5. Okay, and then I'm going to take the second row, so again next 5, so I'll append here. Okay, 1 2 3 4 5. So for example, only I told 5, so instead here we are having 28 cross 28. So image, it will have a more number of pixels based on the resolution, and the size we take 28. So each and every row get appended to form as a single row, which has now 784 pixels. So that's right, 28 cross 28, that is 784 pixels. We just flattened it. Okay, we just flattened into a single row. Okay, in the single row, and then what we are going to do is we are going to take 10 neurons. Okay, I'm going to take 10 neurons for classification of 10 numbers. Okay, what I'm going to take is 10 neurons. Okay, I'm going to connect every 784 pixels with the each and every neurons. Okay, here there is no hidden layers, right? You noted down. So now I'm going to connect each and every layer, each and every pixel to the each and every neurons. Here only I have 10 neurons. Okay, so each and every 784 pixels got connected to each and every neurons. Okay, so I'm going to connect it. Okay, now I'm going to apply a softmax, that is activation function. So here ln is equal to e power ln divided by modulus of e power ln. So here L represents x dot w plus b. So now I'll tell you what is x and what is w and what is b. Okay, so this is the main thing. So here y is equal to softmax of x into w plus b. Okay, x dot w is nothing but a dot matrix. Okay, like product or multiplication. Okay, here x represent the image. Okay, what is it? Image, input image. Okay, here how much image, what image which you have, image with having a 28 cross 28. Okay, here we are having 28 cross 28, that is one single image. Okay, this is the nothing but a input image, and w is nothing but a weight. Weight is nothing but each neuron some specific values based on the pixel. It will start from 0 to 0.9 or something. It will start from 0 to 1. Okay, 0.1 it will be 0.9 it will be. Okay, so 0 to 1, so 0.1, 0.2, 0.3, 0.3, some kind of values which will tends to for every neurons. Okay, so that is weights. Okay, and then third we are having a kind of a bias. It is also known as a concurrent values for each weights which we have. Okay, so these are all like complete structure, which is a this is the softmax activation function equation to do a prediction. Okay, and then what I am going to take is now before we have seen only for single image. Okay, while doing the training or while doing the classification, while doing the training, we can't do with the single image, right? We need to deploy for hundreds of images and thousands of images. Okay, so I'm going to show you how to apply it for more number of images, how it will work for 100 images of 100 number of images, 100 images at a time. What I'm going to do is, first, if you see here, this is the input image. So this each row represent a single image. Okay, so we already seen this one. So single image, this is 28 cross 28 images. It get flattened to form as a single row. Okay, now I am going to take 100 images. So what the structure will be? 100 flattening structures, 100 flattens, right? So if you see here, so here I have done 100 flattened images, 100 images. So what are the matrix will be? 100 rows with 784 columns. So 784 columns represent 28 cross 28 matrix, 28 cross 28 matrix of images, single images. So I have flattened 100 images to form a complete one matrix of which containing 100 images with 28 cross 28 pixels. Okay, so I'm having one matrix. This is the input image. So this is nothing but an input matrix. So here input represent the X. Okay, so next what we are going to take is weights. Okay, so weights is nothing but so first we'll consider weight is nothing but it will connected with every neurons or every activities, right? So for that we'll take a weights. Okay, for every connections we need some kind of values for each and every matrix. Okay, what I'm going to take is we are going to take it for 78410 cross 10 matrix. Why? Because on the output layer, how many neurons we gonna take? Only 10. So if you see the structure, is there any hidden layers? No. Okay, directly I'm going to take certain like flattened input image, that is X. Why? Because if I show this with the hidden layers, it will be little confusing. Just forget about the hidden layers now. So just try to imagine with it. Okay, so now take a certain image, get flattened, and here we are having 10 neurons. Okay, there is no intermediate hidden layers. So same as like now I am going to deploy it for 100 images. So we need weight for that. So we need it already have weights for that. So for that weights we'll have 784 cross 10 matrix. So 784 rows with 10 columns. So 10 represent the output layer, and then 784 represent image. Okay, single image with the 28 cross 28. So these are the weights. Okay, so now we got input and then weights. Okay, so now we got X and then W, X and then W. Okay, now what we have to do? We have to do a dot product of, that is nothing but a multiplication of X with the W, that is input image, input images with the weights. We need to do the dot product. Okay, so on the dot product we're going to do. So here there is each pixels or data. So each pixel or each data or rows or columns will be going to do the dot product with the weights. Okay, input image with the weights, you're gonna apply a dot product. Okay, the dot product will result to you another matrix. So that another matrix I represented as here instead of W, it's everything is real. Okay, so this is the output which is obtained from the dot product of input image and the weights. Okay, this is the output of the this area. Okay, X dot W, that is dot product of which dot product of X and W. Okay, and then what I'm going to do is I'm going to sum of the bias. So bias is also, they are represented as 0 to 9, that is 10. Okay, so 10 which is represent for final neurons. Okay, so the formula is to do the dot product of input image with the weights and do the some with the same values with the bias. Okay, so this is the normal basic structure to how to design those things. Okay, so if you take internet TensorFlow, okay, it is very easy to use. For example, if you do a matrix kind of multiplication, like a dot matrix for every matrix, you can use simply syntax which is known as TF. TF is nothing but TensorFlow. We can import as a TensorFlow one matrix multiplication of x and w. So here what is the x? So 100 cross 784 matrix with the 784 cross 10 matrix. I'm going to do the dot product and the biases. The bias is nothing but bias of 10 values, and then it will give you the it will give you the result with the y, that is like kind of further prediction values. So this is the thing. And after after crossing over this, we are going to discuss about the cross entropy. So cross entropy is nothing but finding kind of probability. Okay, finding kind of probability. So in this, so for example, if you take this area, so if you take this layers, okay, this is the final thing. Okay, here what is the required thing which we have to do is we need to predict the what is the input image which is given. For example, if I give input image as 2, here this second neuron, sorry, this is third neuron. Third neuron should be activated, and this value it should have more number of probability it will show. For example, if we take values from 0 to 1, so for 2 it will show 0.9. So that is the maximum accuracy which we got to classify, that is 2, which when compared to the other neurons. Okay, and then we'll move on here. Okay, so if you take last neuron structure, so it has 10 neurons, right? 0 to 9. So on the 0 to 9, that computed probability is it will have some kind of weights are loaded. Like second number has more computed probability, which is 0.9. Okay, that 0.9 represent it has more accuracy. So more accuracy in the sense when compared to other digits. Say character number 2 which has more accuracy, so it will give you the character number 2 is the right one. So actual probability will detect or will make rest of the values to be 0 and 2 is to be 1. So that certain neuron will be activated. So it will be activated to classify, that is number 2. Okay, this is will be done in the cross entropy. Okay, and then if you're going for application of deep learning, there are a wide variety of application, guys, regarding the deep learning. Because nowadays every industries are moving towards deep learning and artificial intelligence. The reason why we are move on to the artificial intelligence application, first one is human can't work for 24/7, right? And second one is human can't work with 100% accuracy or performance all the time. So to reduce the human efforts only, artificial intelligence have been made to do a performance or application with high accuracy with a good performance. Okay, so that's why we are moving into the artificial intelligence applications. So if you are going to do the in a specific of application of deep learning, it is based on vision kind of application and voice or audio kind of application. So we know that vision can be done using convolutional neural network, and audio kind of thing can be done at a recurrent neural network. Okay, that is NLP. So if you take first medical application is A.I. doctor. So A.I. doctor, so this coronavirus, if you talk about the coronavirus is going intense everywhere, right? So every hospitals are it's very risk to go to hospitals and to talk with the doctors and everything. So by using this deep learning algorithm, by using this artificial applications, we can deploy one robot. It is already done by some other industry. I forgot the name actually. So they have developed one robot. It will be placed in the entrance of the hospital. Okay, whenever the patient enters, first it will recognize the face. Okay, face recognition, and it will recognize the face and it will ask for the name. So asking the name, those going into the natural language processing. So and then after they said the name, it should recognize the name and it will note down in the Excel, like this is the name and this is the appointment which is fixed for a certain patient, and it will open up the thermal camera. Thermal camera will identify the temperature. So it will first monitor the temperature, whether the temperature is good or not. So that if the temperature is high, so that it will say temperature is high. Then do you have any throat problem, throat infection, or do you have any breathing problems? So it will ask automatically to list out the symptoms or causes of the patient to make a database of a certain patient. And then after collecting everything before the appointment fixing, it will forward those details to the doctor, so that doctor may decide when he has to come to the next review or something. So it can be done by using artificial intelligence application. So by identifying the symptoms or prescribing the medicine based on the symptoms. So this is kind of a real-time very great application. And second one is prediction of disease and medical images. So this for same application also we can take same coronavirus or diabetic retinopathy. If you take if you have attended a previous session, you will let you know, like we'll done real-time coronavirus detection by using a medical image to classify a diseased and healthy lung images or not. And then diabetic retinopathy is also kind of retinal diseases in the eyeball. It will have blood leakage, that is known as diabetic retinopathy. By using a medical images, by deploying a deep learning algorithm to classify the image. So we know that so deep learning is nothing but a baby. Whatever the data which we feed, and we will categorize to that one, it will learn that it also. So and then what we are going to do is I'm going to give a diabetic retinopathy images, medical images, to the deep learning model, and good retina images of the deep learning to the deep learning. So it will start studying of every images, and it will do the recognize this is the diabetic retinopathy, this is healthy one, and this is diseased one, likewise. And then third one is voice recognition for ALS patient. ALS is nothing but amyotrophic lateral sclerosis, which is kind of device which will let over some kind of paralysis little bit. They can't able to talk properly. Their voice is completely miserable. It can't able to understand. It is not understandable easily. So by applying recurrent neural network, so that we can do training on natural language processing to recognize their voice itself. So we can deploy one voice assistant for them itself to recognize their words for saying that application. So it should be recognized properly as application. So like a kind of thing can be developed or deployed using these kind of recurrent neural networks. So there are a wide variety of deep learning application. For example, if we take fruit and vegetable classification, if you after segregating, so we need to classify the good fruits and bad fruits. It can also be classified by using a deep learning, because if you are doing with a high manpower with a huge quantity of cultivation, it is very difficult. So we can use deep learning model to do those kind of classification at very short span of time with great accuracy. And if you are having good cultivation or farmering, so there we require is to monitor the leaves or monitor the plants or crops about the diseases, and we need to prescribe the right pesticides. We need to spray the right pesticide. That can also be done at with the help of artificial intelligence to identify the leaf diseases and to spray and to give the related pesticide based on the diseases which it causes. So this is kind of another application. And AI in cooking, it is highly interesting since they are some of the industries are trying to identifying the pattern of the molecular structure of every food products to give you the new food product. For example, milk and milk, everything is a poultry product, right? Without using poultry products, we can give you the same taste and same texture with the help of only vegetable products. It is also possible by understanding the molecular pattern. For example, if you take molecular pattern of milk and then molecular pattern of cabbage, okay, there are some similar property of similar molecular structure while in the aspect of color or taste, okay. So there's same kind of molecular structure will be identified to give you the new products, okay, new food products, okay. That is in the AI in cooking. And in the voice assistants, we already seen that for ALS patient. So voice assistants like Google Assistant or your Siri or Amazon Alexa is work on natural language processing and natural language generation. with the help of recurrent neural network, and Facebook also uses that same recurrent neural network for kind of prediction of words based on the previous word which I already looked for or previously searched for. And then AI in autonomous vehicle. So an autonomous vehicle, what do you think about autonomous vehicle? Do you heard about Tesla? I hope you all heard about the Tesla, very leading company on autonomous vehicle, which will already on the road to navigate or to reach the destination without any driver. So if you your memory, just think on it. Okay. So what are the qualities of the driver? So what are the quality means? First, quality of driving skills. So they should drive properly. And second thing, they should reach the destination. They should navigate from source to the destination point. Second, and third one, they should obey the traffic rules like traffic signals or crossing over the lanes. So those kind of traffic rules and stop signs, limit detection, those things. And then fourth thing which you required is like pedestrian detection or detecting intermediate vehicles. So those kind of things which is required for a driver. So those kind of intelligence will be fed to the machine to do autonomous vehicle. So so there are a lot of application which is nothing but pedestrian or vehicle detection. So I'll show you a little bit video. This is obtained from the Tesla vehicle, which already monitors the road signs and cameras or anything. So this is kind of video that I'll play you. So if you see this one, so here it also recognizes the stop sign before itself, right? And then it also recognizes the nearby vehicles, and also it will also recognize the lanes. And here there are applied lane following and lane detection, and it detects moving vehicle as well as parked vehicle, and it also detecting the pedestrians where they are moving on. And these kind of application will be done with the help of the deep learning, with the help of artificial intelligence applications also. Okay, so this is the thing. So we'll move on to the demo session. So first thing I'll show is first we'll see the character recognition. Okay, give me a minute. So this is the character recognition code which I have opened in PyCharm. So Python, this is based on Python. So Python, you can able to run in Jupyter Notebooks, Spider, or Google Colab. So Google Colab is also cloud-based services which you can run your program in the cloud itself, or else you can, if you want to do a high computational power, for example, if you take any machine learning algorithm which you have more number of data sets, that is like thousands of images, I'll recommend you Paperspace. Paperspace is kind of cloud services which you can choose GPU machine based on your requirement. For example, if you take 1 lakh images, you're going to do a deep machine learning algorithm for 1 lakh images, you can choose Paperspace with the certain machines. Based on the machine which you choose, the charges will be applied. So those kind of Paperspace cloud you can use for machine learning application, whether you have any CPU issues. So that is just little recommendation. So we'll move on here. So here this is character recognition. Here I'll choose any other unknown languages. Okay, for other unknown languages I'll choose let us take Gujarati. Okay, so Gujarati language I'm going to do Gujarati character recognition. Okay, so this is the unknown characters. Okay, so even I don't know about Gujarati. Okay, so here if we take test images, so we are having some amount of test images. Okay, so this is known as ba and cha, sigat, da. So a lot of characters are there. So test images we have already trained it actually. Why? Because it will take some time to train it, so that's why I have trained already. So here there is demo3.py. So this is the code, and then model.h5 and model.json. So JSON is nothing but a model file. So we have already seen the model, how the structure will be. So JSON is nothing but a kind of dictionary format. So dictionary, you know, right? So dictionary, each word can be identified by its keyword. For example, if we take coronavirus statistics, so based on the age, based on the gender, or based on the city, based on the thing. So city is the keyword. So it will in the form of the dictionary. So that is the JSON. And H5, it is nothing but a weights. So we already seen the how weights look like. So and then this is a demo. I'm going to run this one. First I'll show you the graphical processing unit. Sorry, I'll show you the GUI of the this application. Okay. So it is running. So for example, if you show here, so what is showing using TensorFlow as backend, we have already shown you. Here I'm going to use a Keras. So we know Keras is very easy to use. Here TensorFlow is used as backend. I told you like Piano or TensorFlow can be used as a backend for Keras. So here we have used the TensorFlow as backend. So this is the graphical GUI. Okay, graphical user interface for Gujarati character recognition. Here we are having push buttons like browse, classify, and then training. I'm not going to do the training now since I have already trained it, since it took about 30 minutes. Okay, so this is like text boxes which will show you the result. So this is Gujarati recognition. First I will explain a little bit about the code. So first I already told you Keras. I'm going to use a Keras. In the Keras I'm going to use intermediate layers also. Okay, so this is based on completely convolutional neural network. So can you tell me about the convolutional neural network? What are the common layers which we'll use? Can you tell me? So first one is convolutional layer or pooling layer or fully connected layers, and then final softmax layer. So every layers which we required is it should be imported, right? So flattening we have imported flattening, and max pooling we have imported max pooling, and the convolutional two-dimensional, and to save the model we have used a model, and dropout, and then batch normalization. We have imported every Keras libraries which are required for our application. Here Py which is required for that GUI. Okay, just a little bit for the GUI. Whenever you are pressing the button, what action should be performed. So those kind of applications with the help of is really done with the help of PyQt. And these codes is responsible for designing that graphical processing unit. For example, the classify button, and then label, and then training, and text edit boxes, and then menu bar. So those kind of designing will be done here. And here these three lines are responsible. For example, if you click the button browse image, what it should do. So it will call the load image function. If you click the classify button, what the function it should call. Click the training button, what the function it could call. And then what it will do now means here we are having some functions. So first we'll see the load image. So load image, when I click the browse button, what it should do. Okay, so in the load image, what we are doing is we are designing some widgets to open the image. So image can be in the format of PNG, JPG, JPEG, or BMP. Okay, so it should be loaded and it should be displayed in the image label at the center. Okay, shall we see this load image? So browse image, I'm going to click the browse image. I'm going to choose the image which I have to do the classification. Okay, I'll choose ala ala. Okay, so I chose the one character. So this is the function of this load image function. Okay, and then second thing what I'm going to do is I'm going to do the classify. Okay, so before classify we'll see the training. Okay, so this is the structure we have already seen in the presentation. Also we have seen that structure, right? So for example I can show you it again. So this is the structure. So first we have to design the structure like convolutional layer. Each and every layer we need to design it. So this is the representation in the program there. So first we are initialized as a sequential. So and before that I want to say about certain things. Okay, so you have heard about the machine learning and the deep learning, and someone may hear about the transfer learning. Okay, I'll tell, it is not mentioned in the presentation, but I'll tell it now. So the transfer learning is also one kind of very interesting concept. So if you start any deep learning application from the scratch, we need to specify each and every layers, and weights will be developed at every time first initially from you start. Okay, so weights will be initially, it will be like some of the values, so weights will be there. So that kind of classification is also there. So for example, if you do some kind of training with some kind of more number of images, but you can also use the pre-trained model. For example, if you take Keras itself, there are some kind of object recognition like MobileNet SSD, VGG MobileNet SSD, VGG16, VGG18, YOLO. So these kind of models are pre-trained models. So for example, if you take MobileNet SSD, it is trained for lot of images of some of the object. That code is used, that model is used for object recognition. So for example, it may classify aeroplane, and then car, and then truck, and then person, and then monitor, and then potted plant. So it can classify these kind of 5 objects. So for that that model will be very great accuracy they have trained for. Why? Because they have used lakhs of images for each classes. Each classes is nothing but lakhs of images of aeroplane, lakhs of images of TV monitor, lakhs of images of potted plant, like that. So it already, that neural network, that designed neural network, it already contains a neural convolutional, weights, right? So for our different application, for different kind of a program. For example, if I need to classify the object for different say I want to classify the object for different objects. For example, other than the MobileNet SSD, I want to classify I need to classify some kind of pen or some shirt or something. So if you want to kind of data, if you need to do that kind of data, so we can use that weights. Okay, we can use that weights which is already done in that MobileNet SSD for our application. Okay, so this kind of layers is designed by using model.add and convolutional layers. We have trained for activation functions or ReLU functions. At the final stage of area, we have included the softmax. You know what the softmax will do. That's why I have explained softmax function. And then before processing into the model, first thing we need to do some pre-processing in the image. For example, we need to specify the size. What is the size of the image? For example, each model will be different. Each model will different with their size. For example, if you take MobileNet SSD, it has pre-request the image size should be only 127 cross 127. If you take VGG16, it may have it should have 229 cross 229 image only. So it has some pre-requesting specific size it should specify. So before processing every image to the model, we need to specify the size of the image. Okay, size of the image. So those kind of pre-processing should be done. So by converting those images into gray or binary, so those kind of pre-processing will be done here. And then we need to specify model properties. So here we have to done it for 2 things. One is training as well as testing. So testing data set and training data set, both we have to specify the parameters, what the parameter or what the target size should be. Okay, here the batch size is 32. If you are facing any computational problems, you can run the batch into lesser number. So batch is nothing but if you take 32, it will take a huge part of the image and it will process more number of data at a time. So if you reduce the batch size into 16 or 8, it will reduce the batch size into very smaller area. So it will process smaller area at a time. So first it will process this area and it will move to this area and here, instead of processing this huge area of a single image. So that is nothing but a batch size. So this kind of thing should be specified before itself in the both for training as well as the testing. Okay, and then we have to fit the model. So here models can be fit by specifying the epoch and validation data. So for validation we'll use the test data set. So other than that, we need to specify how much epoch should be. So epoch is nothing but how much iteration should be performed throughout every images. So for example, this 100 images and the pen images with 100 images. So how much iteration should be? Should be iterated for single image. Okay, so that is nothing but epoch. So epoch, you can put up a high epoch for having a good accuracy to have more number of trainings. Okay. At the final stage, what we are going to do is we are going to save the model in the name of model.json, and we are going to save the we are going to save the weights in the name of model.saveweights, like in the name of model.h5. So this model keyword, this is very useful while using a Keras. Why? Because Keras itself, it will have inbuilt function which is required to save the model or optimize the model or generate the model or fit the model. Any model, it has certain syntax. So by using a certain simple keyword like model.save, weight can be saved in the name in the certain directory of your local PC. Okay, so this is the training process. So it will do the training and will give you the it will print you the result with the accuracy and the loss. Okay, and then if you click the classify button, what it will do? First it will load the model, that is model.json, and then it will load the model.h5, that is weights. So after loading the model and then its weights, then I am just initialize the label, that is so here what is the final stage of convolutional neural network layer? This is the label. Okay, how much character in it? So based on that we will specify the neurons. Okay, at the final stage, only one neuron going to be activated which has more number of values which we have seen in cross entropy. So that based on that we will tell that this is the predicted output. Okay, I just initialize the label. Okay, and then I have initialized the target size also, like 128 cross 188. Why? Because input and the processing area also it should have the same size. And then after that we are going to check the test with the model. We have already loaded the model. In the keyword I am going to pass the argument of the test image. The test image, which is nothing but which is already loaded in the GUI. Okay, and then after that it will give you the probability matrix. Sorry, probability list or probability array. Okay, so that probability array contains some kind of inside the square braces. For instead of this label name, it will give you the point values like probability, like Suna means 0.1, Ek 0.2, Das 0.6 or something, some kind of value. Among the complete label, among the complete area of matrix final stage, at some of the only one of the values it contains huge number of probabilities, like for example 0.9. So we can able to identify that is the right label to choose that is the prediction values. So that's what we have did in here. So label to predict the label. So to have a it is a number character. So I can show you the demo now. So we have already browsed the image which it have to show. Again I will browse the image and I'll choose the image for you. So now I am going to choose the character Allah. So I chose this one, and then I am going to classify it. So if you see here, so it is classified as Allah. Okay, if there is any Gujarati, don't mistake me, I don't know Gujarati. Okay, and then I'm going to choose another image. I'm going to choose bar. to click classify. So it is recognized as bar. So this is simple convolutional neural network. Since the no transfer learning is used, we have started from the scratch, and we have designed convolutional neural network. So normal CNN, which contains a normal convolutional layer and pooling layer, and then fully connected layers, and then at final stage we have included the softmax for activation functions. So finally I activated the certain neurons to classify it. Okay, so this is for Gujarati character recognition. So same as like only the data set gonna will change it for different languages or handwrittens or anything, but same code we can apply for wide variety of application to the character recognition or any binary image classifications. Okay, and for emotion recognition. Okay, so for emotion recognition, first thing, so for, let us take normal emotion recognition. What is the first thing we need to do? First thing we need to do is detecting the face from complete background, right? So detecting a face, for that what is the feature we require? Face detection, like which of we can use a frontal face detection algorithm for detecting the face, right? After face is detected, what the second thing we have to do? We need to detect the emotions. So emotion can be detected in different ways. So you have already heard about 68 landmarks, right? So for face recognition or anything, 68 landmarks are the responsible. So landmarks is nothing but so 68 landmarks are nothing but a kind of 68 dots. Okay, 68 dots will be placed in every part of your face, only face. Okay, so for example, if I take 68 landmarks and I'm going to place it in my face, so it will place landmarks in here, like in eyebrows, in eyes, and the noses, in mouth and ear. So likewise it will place the every landmark. So if I'm laughing, so that landmark will change its position from its original state, right? So or crying or surprising, so while surprising I'll open my mouth and my eyebrows got expanded. So those kind of facial features can be extracted. Okay, here the first thing is required is facial landmarks, and second one is first one is face detection, face detection using face detection, and then second one is we required is facial landmarks detection, and then third one is we apply a deep learning algorithm which is already trained for sad face, disgust, scared, happy, cry, surprised, neutral. So those kind is already trained in it. Okay, so for here since my webcam is already in use, I'm going to use my mobile camera for emotion recognition. You can also use, if you have Android mobile application, if you have Android, you can use you can download and install IP webcam. For every deep learning application you can use your mobile phone instead of purchasing a new camera and interface with your laptop or system. Only thing, the laptop and your mobile phone should be connected with the same network. So I have already opened a camera now. So okay, so here it is. I'm going to run the application. It is loading actually. So initially it's showing neutral. So when I'm doing it's showing happy. So now it showed cry. So it shows surprised. So again it come to the neutral. So this kind of application where it can use is it can be used for real-time traffic cameras are there. A lot of traffic cameras is there, right? So traffic cameras we can deploy this for citizens emotion detection. For example, if they are going to do something, is they are scared or is they are not good looking or is they are normal. So or is the person is having some problems. So likewise we can able to detect. So likewise we can able to detect by deploying it in the real-time traffic cameras to detect any vulnerability, or we can place this application in the drones for surveillance for any mistake or thing happening in the city areas where they can't monitor at real time. So we can use or we can deploy these kind of applications at a so we are almost into the session. In the actually deep learning can't be finished within 2 hours or 1 hour. Why? Because it has plenty of thing which is required to say. Okay, it is up to a question and answer session. I'm on the live chat. If you have any doubts, can you give it in the live chat? If it is old old questions, I will go through the live chat and I'll reply you later on. Now I am waiting for current live chat for questions. You can give the questions. I'm waiting for your questions. Bhavya Reddy who asked us differences between artificial intelligence and deep learning. So actually artificial, there is nothing like differences. Like artificial intelligence, I have shown the circle, no? So that is the artificial intelligence structure. Inside that we are having machine learning, and then inside that deep learning. So that is the complete bunch of artificial intelligence structure bar. So inside that deep learning is one kind of very in-depth application for classification and recognition. Okay, that's the thing. And how AI helped me for research, Saroj? Actually, that is based on your research for kind of publishing, or even some of the companies are so predicting the forthcoming publishing throughout the year based on the previous data set. For example, if the research is based on the road accident analysis, there is some kind of machine learning predictions. Why? Because in road accidents, there are based on different kind of parameters like bikes, based on the bikes. For example, if you take a KTM Duke, so that kind of vehicles will lead to more accidents based on that speed, and the age it is up to 18 to 25 age will have more accidents. If it is a gender based, it will be men more than a woman. So based on that, by feeding those knowledges for our past 5 years of accident data to the system to predict what may be the accident cause on the 2021. Likewise, we can predict based on the requirement, based on the application we can choose. Um, How can use deep learning and artificial intelligence? Yeah, deep learning architecture, deep learning is used for kind of image-based classification or video-based classification, especially a convolutional neural network. If you take RNN, it is used for voice kind of application. Techno PVR difference between machine learning and ML. Yeah, machine learning, I already told you, machine learning is for same thing, same data is needed. For only thing is machine learning, we need to specify the features. In the deep learning, it doesn't require to specify the feature. It will automatically identify the feature. It is a little bit advanced than the machine learning since it is automatic. Yeah, it is possible to work with deep learning in cloud computing also. And I want to say is like some kind of deep learning cloud is also there. Some kind of applications like Amazon Web Service, that is AWS. They are providing cloud-based services for deep learning. For example, if you take a lot of services in AWS, that is Amazon Web Service. In the Amazon Web Service, there is some kind of application which is recognition, which is used for object recognition. If you feed any images in there, it will give you the result. For example, if you give any city areas, it can also able to recognize the vehicle tires also. It is very effective, like they are trained for millions and billions of images, I think. So it can able to identify the shadows even. It can also able to the person, and it can able to differentiate the shadows with the person also. It is very effective. You can try. How it will be used for government projects? Yeah, government projects, there are a lot of government projects regarding based on the application. For example, if you do some kind of analysis like COVID-19 detection or prediction, that is also kind of government prediction, so that we should be very safe enough now. So like as the government take decision now, so we can able to predict those kind of things. So on the other aspects of government, if I say for surveillance or anything, we can put up artificial intelligence based on application on every traffic light cameras or in drones or streets areas. Nowadays every cameras are simple for surveillance, right? It is only record the human going and everything. So every cameras is just for recording. So if any disaster or if any vulnerability happened, after only they will go to the camera and they will see, okay, this is the person who murdered. So we have to catch the person. This is very useless, right? Only we can capture, but by using artificial intelligence, we can, at the vulnerability happening at the time itself, we can predict, or we can say some vulnerability happens in the 45th street of this Chennai, so that you should go. So it will alert the cops to go in there at the right time, so that to avoid the vulnerability. So there are a lot of applications. Can we create direct torque control of permanent magnet synchronous motor using, yeah, some kind of deep learning machine learning algorithm which we can deploy it for hardware also. If you need it in hands-on, just better to choose Raspberry Pi. Why? Because Raspberry Pi or Jetson Nano. Why? Because so if it is going for hardware based of artificial intelligence application, we need to do a data set or we need to do a training. For example, I can give you some certain of links for power theft identification in electrical department using machine learning. There what we take is we consider two loads with the 60 watts and 40 watts, and we will monitor every values. If they have any problems in air conditioner or some kind of power fluctuations are there, it will be detected and it will send the mail to the user. And power theft identification can also detected by using machine learning, and it will send alerts to the electricity department, like they are consuming more power than usual. Like that you can deploy machine learning algorithm. It is also possible. Rishi Bharatwaj, it's interesting question. Like, is it practically possible for the application for deep learning to differentiate between a friend and foe without any storage pictures? Yeah, that is also can be detected based on the emotions also, friend or foe, how they are speaking. It is based on voice or is it based on a video? If it is based on voice, how they are speaking skills are. If they are speaking very kindly, they are respectful or they are friendlyful. Based on the data set which is provided, which you provided. Let us take a small baby, a small baby. Okay, what you teach with a baby, that baby will gain the knowledge. Like same as like a machine. If you teach properly, it will do the need for you. So, hello, sir. I would like to know that how deep learning can be used for detecting the pre-mental health symptoms. So that is there is two ways actually. One is based on the images of medical images, based on the medical images, or it will be based on the raw data of symptoms like doing some unnecessary things or being idle. So based on the data which we provide, the algorithm we can apply it for recurrent neural network for natural language processing, whether they are speaking properly or they are missing some words or they are speaking is completely ununderstandable. So likewise we can able to analyze those things to say they are some kind of deficiency are there, or if you're going for any image by actions they are doing, so those kind of things also can be done. And I'm getting a lot of questions, so it's already time. So if you're having any doubts, you can give it in comment box also, so that we will go through it every comments and we will reply for each and every comments in the comment box, so that everyone will be benefited through the comments. And this is the and we are having upcoming sessions of May 30th with conversational bot design by using Google's Dialogflow. So here will I hope will rise up a polling like the hands-on, or it will be a complete like session like this. And on the April 2nd or 3rd, that date I'll confirm you later, that based on a brain computer interface we will show you a real-time brain and computer interface. I'll place the device in my head so that I can do attention meditation, and I'll play some games. I'll give you live interaction on brain and computer interface. And yeah, role of DL is in IoT. Yes, everything is possible. Like if you go for industry 4.0, like predicting, it is kind of IoT as well as artificial intelligence. Like now I am going to get out from the home, so it will automatically identify the traffics or anything in the area, and it will send me a notification in my car dashboard or in my mobile, like there is some kind of traffic gonna be in this way, just better to take that way. So likewise IoT can be deployed with artificial intelligence also. Thank you so much, thank you. Please leave the comments guys if you have any feedbacks, or if you have any suggestion about any topics like brain computer interface or any kind of interesting thing, you can give it in the comment box below, so that we will schedule based on your requirement on certain topic. So thank you for watching this video guys. It's very glad to have this session with you. Your comment and your suggestion is very helpful for me. Thank you for your comments. Thank you guys. Thank you. See you in the next session. Goodbye.